Calculate the number of moles of calcium carbide, Ca2, added. The sample mass of Ca2 is 0.064 grams, and its molar mass is 64 grams per mole. Use this to calculate the moles of reactant added. N-Ca2 is equal to 0.064 grams over 64 grams per mole equals 0.0010 moles. Determine the moles of calcium hydroxide, CaOH2, produced. According to reaction 1, the reaction of Ca2 with water is Ca2 plus 2H2O is in equilibrium with C2H2 plus CaOH. 2. The stoichiometry of this reaction shows a 1-to-1 molar ratio between the reactant Ca2 consumed and the product CaOH2 formed. Therefore, the complete reaction of 0.0010 moles of Ca2 yields exactly 0.0010 moles of CaOH2. Calculate the initial concentrations of Ca to the power 2 plus and OH to the power negative in the solution. Assume that the produced CaOH2 initially dissolves completely in the 1.0 liters volume of distilled water. CaOH2 gives Ca to the power 2 plus 2 OH to the power negative since 0.0010 moles of CaOH2 is dissolved in 1.0 liters of water. The concentration of calcium ions is Ca to the power 2 plus equals 0.0010 moles over 1.0 liters equals math 1.0 times 10 to the power minus 3 molar because each formula unit of calcium hydroxide dissociates to release 2 hydroxide ions. The hydroxide concentration is OH to the power negative equals 2 times 1.0 times 10 to the power minus 3 molar equals math 2.0 times 10 to the power minus 3 molar. Determine the reaction quotient, Q, for the dissolution of CaOH2. The solubility product equilibrium is CaOH2 is in equilibrium with Ca to the power 2 plus 2 OH to the power negative. Write the expression for the reaction quotient. Question Q equals Ca to the power 2 plus OH to the power negative to the power 2. Substitute the calculated concentrations into the expression. Q equals 1.0 times 10 to the power minus 3 times 2.0 times 10 to the power minus 3 to the power 2. Q equals 1.0 times 10 to the power minus 3 times 4.0 times 10 to the power minus 6 equals math 4.0 times 10 to the power minus 9. Compare the reaction quotient, Q, to the solubility product constant, Ksp. The calculated value of Q is 4.0 times 10 to the power minus 9. The given Ksp of CaOH2 is 8.0 times 10 to the power minus 6. The official exam booklet lists it as 8.0 times 10 to the power minus 8. Since Q less than Ksp, 4.0 times 10 to the power minus 9 less than 8.0 times 10 to the power minus 6, or 8.0 times 10 to the power minus 8. The ion concentrations have not reached the threshold required for saturation. Consequently, the solution is unsaturated, meaning no precipitate of CaOH2 will form. Confirming option D is correct. The correct answer is option D. CaOH2 will not precipitate because Q less than Ksp.